Hey, hi everyone. I hope you all are doing good. So, in my today's session, yeah, I'm going to explain one of the creational design pattern called Singleton pattern, or you can say Singleton design pattern. Okay, we have three categories of design patterns, which is creational, structural, and behavioral. So, in today's session, in a creational category, I'm going to discuss about the first pattern, which is called Singleton design pattern. Okay, the name itself clearly tells, okay, it's a singleton. Okay, so at any instance of time only one object of that class will be available. Okay, so basically the definition of singleton class says that we have to restrict the instantiation of a class to a single object or only one object. Okay, so practical scenarios or applications being you have expensive system resources like a DB connection, which you want to be shared by multiple objects. Okay, so only one object can be utilized by all your application object classes. That is one scenario. And also, for example, there are some application resources or some classes like loggers. Okay, only one instance of such a logger is required in order to log for all incoming requests of your ASP.NET Core application. Okay, so these are some applications where we can implement a singleton pattern. There are many applications. Feel free to expedite on finding such applications on internet. Okay, so without wasting much time, I'm starting with the implementation. How we can start with it? Okay, the first approach, which I call very immature implementation, but still it's a singleton implementation. So it's a public sealed class singleton, so nobody can inherit this class further. And then what I'm doing, I'm putting a private constructor so that this class cannot be instantiated outside other classes. Okay, outside of this class, like from any other classes by using the new operator. So if it contains a public constructor, then only you can create such object. But I don't want it to happen. I want to keep it private constructor. Okay, then I have a private static singleton instance which is set to null, and I am exposing a a static method or a static property. So as I'm making use of C sharp, I have a privilege of making use of a static property. Okay, so public static singleton instance, which has only getter, or you can call a get accessor. So what it is doing, basically it will check if instance is equal to null, then only return create object of this class. So see, I'm instantiating the singleton class only inside that singleton class itself using its private constructor, because I can use the private constructor only inside the class, not outside of it. Okay, so post that I will simply return that instance. So if that instance is already instantiated, for the next time when it comes, this condition will fail, but the instance has been already instantiated, it will return the instance. A very bare minimum and very immature implementation which doesn't provide any thread safety and lazy instantiation of your singleton object. Okay guys, so there is a possibility that through two threads, for example, consider a multi-threading scenario or multitasking scenario where two tasks or two threads are trying to access, trying to get a singleton object, and both will pass this condition if instance is equal to null, and they will end up creating two objects, which will basically violate the basic rule of singleton design pattern. Okay, so immature implementation, not even good for any book writing also, which I can say. Okay, so let's go on to a little bit optimization or little improved version, I can say. A basic thread safety. So let's see what thread safety we are getting. Okay. So here, what I have done, public sealed class singleton, same as the previous implementation, public static singleton instance is set to null. Now I have an static object, okay, a system.object I'm using just to ensure lock on this particular class. Okay, so the object on which you acquire a lock should be static or shared object to your class. So that's why private static read only object padlock equal to new object. Okay, then the private constructor. Okay, and then what I'm doing, I have again exposed a static property. Okay, so public static single instance, that is the one, the name is instance. So here what I'm doing, I'm simply put a lock, the C sharp lock keyword on my padlock, that is the shared object. Okay, so a very minimal, okay, a bare minimum thread safety I have provided. So if two threads try to access this particular instance, so if one thread first accesses or acquires this lock, then other thread have to wait until that thread finishes this particular block of code. Okay, so this way I ensured thread safety in particular in this particular implementation. Okay, so again, a basic level thread safety I have provided. So now it is little thread safe basically. Okay. So next move on to the next level of improvisation. Okay. Yeah, one more thing I wanted to discuss, guys. There's one more worst approach people follow, the concept of double checks for a singleton design pattern implementation. Okay. Same as the previous implementation, only thing is the moment they get into the get accessor, first they will check if instance is equal to null. Then once a thread acquires a lock, once again they will verify again the instance is equal to null or not. They think that if due to some reason or by some other thread, if it is get instantiated, then you will end up in creating this object. But I don't think so which is going to happen, and some programming languages won't support also. So this is also one worst approach. Don't follow this. Okay, then we'll move on. Yeah, thread safety without locks. Okay, because using this kind of multiple conditions like if conditions and then locks, basically it will decrease performance little. Okay, it will decrease the performance, so I want to avoid that. I want to avoid these statement executions, ifs, locks, everything. So now I'm going to utilize some of the core features provided by the C sharp programming language. Okay, so thread safety without locks, that's the basic version. So what I'm doing here, private static read only singleton instance equal to new singleton. Okay, then I am adding a static constructor here. Okay, so I'm adding a static. Okay, I have a private constructor as well as now I'm adding a static constructor. Okay, I think many people would have known what is the basic use of a static constructor. A static constructor will be initiated or executed only once for an application domain, and that too when an object of that class is instantiated or any static field is accessed. Okay, so this is how I'm basically ensuring that my this part of code will only executes once. Okay, only execute once. So that's why they have specified that the explicit static constructor to tell C sharp compiler not to mark type as before field in it. Okay, so in C sharp, basically whenever we create a plain C sharp class, if it doesn't contain a static constructor, then our C sharp compiler will by default mark it as before field in it. But the moment it contains a static constructor, then it will not mark the class or a field as before field in it. Okay, so that's why we are explicitly specifying this is not to mark it as a before field in it class. Okay, now what is going to happen, see here guys, public static singleton instance and get, that's it. So whenever a first reference has been made to this singleton class, whenever the first reference has been made to this singleton class by its static field. Okay, see, there are two ways to instantiate. Okay, there are two ways to trigger a static constructor in a C sharp class. First one is make explicitly making use of a new operator to instantiate that class. But in my case, first of all, I have made my constructor as private, so there is no chance of instantiating object of this class outside of this class or from any other classes. So that is ruled out. The only second option which remains is basically accessing the static member of this class. So the moment when they try to access this instance, that is the public static singleton instance property, that time this particular field will be uh, triggered, or I can say instantiated. Okay, for the first time you are accessing this instance by this property, that's why it will instantiate this object and it will return that object. So then onwards you will keep on returning that already instantiated class itself. Okay, it won't execute again and again because it will create this instance only once because it's a static field. Okay, so this is the thread safety without locks. This is the basic version, so let's move on. Now, better lazy instantiation. Okay, let me tell you what is the problem with this implementation. This doesn't ensure the lazy instantiation of your object. Okay, so there will be scenarios where basically you don't want to instantiate your singleton object. Okay, you want it to be instantiated only when it is accessed. Okay, but what happens is in this particular case, the moment any static field, just imagine your class contains multiple static fields. In my case it had only one here, okay, that is instance. But suppose imagine if I had one more static field here, and due to some reason or due to some requirement, if I accessed that static field, then it will immediately execute this line of code and it will create object of my singleton class, which is eager loading. But I don't want my singleton object to be used anywhere, but still it got instantiated. So to avoid that, we will go to little improvised version where basically I am applying a better lazy instantiation, where what I'm doing, I have a private singleton constructor. Okay, then I have my get accessor, a static property, okay, which is called instance, okay, public static singleton instance. And what it is doing, okay, provide observation guys here, okay, provide your attention. See, it is what it is doing, it's a get accessor which is returning nested class dot instance. Can you see that? Okay, and I have created a private class inside this actual singleton class. And what I'm doing, again I'm using the concept of same thing, I am introducing one static constructor to tell compiler, okay, not to mark it as a before field in it, this particular type or class. Okay, so what happens is, until and unless I don't refer nested class dot instance, this object won't be instantiated. Okay, so even if my singleton class, okay, has some other static fields over here, okay, even if it has some other static fields over here, so just by accessing those static fields, okay, my instance won't be created, because that instance creation logic, okay, has been delegated to a inner class or a nested class. Now it is completely the responsibility of this nested class. When it is explicitly accessed, then only I will get my singleton object. Okay, I hope you people understood. Okay, here I had a threat that if my class would have had some other static fields, okay, even if I don't want my singleton instance, but because of access to those other static fields, my instance got instantiated. But here now I have basically eliminated that issue. What I have done is, okay, I created my singleton class, but inside that I have created a private class. Its whole and sole responsibility is simply, it is a private class having a static constructor and it has the field, instance field. Okay, so whenever I access this particular field of this nested class, then only it will be instantiated, and not by accessing any static fields of this particular parent class. Okay, so this way I achieved a better lazy instantiation here now. Okay, so whenever I explicitly make reference to this instance property, okay, whenever I make explicit usage of this instance property, then only it will make a call to nested.instance. And as my nested class is basically having a static constructor and it has a static field, that's why it will instantiate this object and it will return it to me. Okay, so that's the logic behind here, okay, to achieve better lazy instantiation. So let's move on. Again, there are improvements. Now, optimized implementation. See, what I'm doing here, I think you people would have provided attention here. I was making use of an inner class or a nested class, which is private class, just nest, which is called a nested class basically, just to nest my singleton instance. Okay, in order to achieve that lazy instantiation. Okay, but .NET framework itself provides a class called lazy. Okay, I think you people have heard about this. Okay, the lazy class is used to instantiate your objects lazily. Okay, a lazy class will only be instantiated when its value property is accessed. Until that, it won't return any, it won't create any object by itself. Okay, so the optimized implementation, public sealed class singleton. Okay, now private static read only, it's a lazy of singleton now. Okay, I'm making my singleton class or instance as a lazy object now. So what I'm doing, equal to new lazy of singleton, and I'm passing what should happen. Okay, how the object, what should happen when my lazy object is accessed. Basically it should return a new singleton object. Okay, and now if you see this public static singleton instance, simple. Here I was returning, in this version I was returning nested dot instance. Now same stuff I achieved using a built-in class called lazy, where I'm returning lazy dot value. That's it, guys. Okay, instead of creating my own custom class to achieve this lazy instantiation, what I did, I made use of a .NET framework or a .NET core provided class called lazy. That's it. Okay, so both are same, only thing is I'm basically making use of already available class called lazy, which is provided by .NET framework or .NET core. Well, you people may be thinking, I think now this would be the optimized implementation, I think ready for and ready for use in enterprise grade software. But guys, there is one more implementation. Okay, see, in this version you created a singleton class. Okay, or you can say a logger class. You can name it a logger or some resource which can be used for the purpose of singleton, but this class is specifically meant for that purpose only now. Okay, you can use this class to create only for that purpose. For example, if I say this logger, and if I put it logger, okay, everywhere. Let me quickly show that. Hmm. Okay, so yeah, that's it. That's it. Right. So this particular implementation over here, this class can only be used to create a singleton object of logger. But if I want a generic class which takes the responsibility of creating singleton objects for me, how will I achieve that? If you are aware of ASP.NET Core development, where you have a flexibility of adding your services either scoped, transient, or singleton, and how you register a class as singleton in ASP.NET Core, you basically call services.add singleton method, right, guys? So there should be one class which should be taking responsibility of getting your registered type, that is services.add singleton of the type whatever you pass, and then using that type it will be keep on creating singleton objects, right? So there should be some generic implementation. So we should our we should create our classes in such a way that it can be used for multiple purposes. So what I'm going to do is, now I'm going to show you a generic implementation ready for enterprise grade software. So have a look here. Public sealed class singleton of t, type parameter I am specifying. So basically I can create any class as a singleton here. Okay, so public sealed class singleton of t, where t colon, it should be a class, and it should have a default constructor or a parameterless constructor. Now inside that same implementation like this, okay, I will be having my lazy field, which will basically, yeah, act as my lazy class. Okay, so private static read only lazy of t. So lazy equal to new lazy of t, and I'm passing when my type needs to be created. Okay, I'm basically instantiating my lazy object. Okay, so when actual instantiation will take place, as per the lazy class definition in the .NET framework, it will create the class only when it is accessed, whenever you call the value method on that lazy object. So if you see my yeah, the get accessor, a static get access, sorry, get property. So it is very clear, public static t instance get return lazy dot value. So whenever I call singleton of t, singleton of any class like singleton of logger equal to yeah, singleton of logger dot instance, then only the lazy dot value will be called. And when a reference has been made to lazy dot value, this particular constructor parameter lambda will be triggered, and it will return a type which you have requested over here, which is t. So if I take an example of logger, then singleton of logger, then when I make a reference to say var obj equal to singleton, assume I have a class called logger. Okay, So the moment I made a reference to instance, guys, okay, this should return me a singleton object for logger. Okay, so what happens, as I already explained, first this is static uh, property will be called like this singleton of logger dot instance, which internally calls a lazy dot value. And when value is referenced, for what this lazy object was created, it was for this type parameter t. And what is the type parameter t here? Logger. So it will return an instance of that by this lambda expression given over here to this lazy objects construct, or sorry, lazy classes constructor. So this is the best implementation which is ready for enterprise grade software, and which is performance oriented, which is thread safe, and it is safe from all the way. Okay, this is the foolproof code you should use for a singleton implementation. Okay, so again, it depends on the need. If you want to create a generic implementation, go with this, which is what most of the time happens. People look for generic implementation. But if you are very sure that I want to create a specific singleton classes specific to some functionalities like logger, like DB connection, like that, in that case, you go with this implementation. Okay. I hope you people understood the concept of singleton design pattern, okay, and what are the good ways to implement that and what are the worst ways we used to use before, okay. Thank you for listening and have a nice day. I hope you people will use it in your day by day development activities. Thank you.